Sorry for the interruption again. So just to kind of recap, so what this is a makeup lecture. It should be working. Let me see if it's chat. Oh yeah, let me just test it out here. So I know this is working. I can't listen to myself and talk at the same time. It's totally distracting. Okay, so yeah, what this is an opportunity, because I know there are like I was saying earlier, about 5 sections left, and we only have about 3 or 4 full lectures together. So I'm gonna go ahead and do these lectures now, or as much as I can, and I'll at least do a 3.1. I know a few of my classes have already done 3.1, so this is an opportunity just to kind of get everybody on the same page. And yeah, so we'll go ahead and move into section 3. So obviously I'm not used to actually being live and actually doing like studio work, but we're gonna let it be and let it be. Okay, so we're here in chapter 3. Let's see, so I know the live chat is working, so I can kind of see when people log in. I think I'm the only one in right now, but anyway, we can't worry about that. So chapter 3, and I can see people's chat, so I'm going to let that be. So 3.1 is on quadratic functions and models. Okay, so if it's quadratic, it'll be like polynomial functions, quadratic functions, graphing techniques. So these are some of the ideas that we're going to explore here. So a polynomial function is a function of degree n, where n is a non-negative integer, is given by what you see on the screen. Okay, so to kind of sum it up, a polynomial function is just a finite sum. Is just a finite sum of of monomials. A monomial is just going to be a term where the leading coefficient is going to be a real number times some variable, and the variable is going to be to the power of an integer exponent, right? So a polynomial function is just a finite sum of monomials. Again, finite being the opposite of infinite. Infinite means it goes on forever. Finite means it cuts at some point. Okay. So here are some examples of polynomial functions. The first one is a constant function. We say that has a degree n. So we call it, we say it has a degree n because we can actually write this as x to the power of 0. Right? So a number to the power of 0 is going to be 1, and then 1 times that number is itself. Let me see if I can go like this. Okay. So then the second row, we have this 5x minus 1. We call that linear because the highest degree is a 1. The leading coefficient is 5. So the leading coefficient is going to be the number in front of the term with the largest exponent, so on and so on. So these are all examples of polynomial functions on the far left. Okay. And yeah, we're just going to kind of let that be. It is a little weird, like here, because I can't hear anybody. You know, I mean, I know it's nobody in right now, but even when they are here, it's just different because it's so like quiet over here. So anyway, I'm just totally distracted. But yeah, let's kind of keep it moving. So we're going to continue the discussion with quadratic functions. A quadratic function is a function of the form ax squared plus bx plus c, where a, b, and c are real numbers and the leading coefficient is not 0. If the leading coefficient were 0, then the x squared term would go away, and then it would no longer behave like a quadratic. All right? Okay. So again, with this live session, I am open to giving extra credit, especially if you're in a live attendance. I know I had one going earlier. Maybe, I don't even know how to get rid of that one from earlier. I had to do it later. But if you are in attendance, and let me turn this on. I feel like this might be a little loud. If you are in attendance to this, I give extra credit. I think I said earlier, 20 bonus points for this out of the 100 for the quarter. So it's a huge chunk, especially if I can see where you're live and you're in attendance or whatever. And I'll accept attendance in the comment section 24 hours after I stop all these videos. Just got to work it out. Anyway, we're going to keep it moving. So the simplest quadratic is the function f of x equals x squared. That's just the traditional parabola like what you're used to. Okay. Can I clear that out somehow? I know there is a way to do it. Let me try this really quickly. I see you, Miss Hilla. That's what's up. I appreciate you. I appreciate all the students. I mean, everybody has something to offer, and it's like I don't think you guys realize like how much you actually teach me, because it's like every time I think I know something, and then you guys come along, I was like, crap, I thought I had this stuff figured out. Whether it's by emotions or something, you know, it's always something you guys are teaching me. So you know, this plane is very, very interesting. Anyway. So we have the simplest quadratic function, f of x equals x squared. So one way that we have to graph something of this nature, the simplest way we have to graph something, I see you, Miss Kamanji, Mr. Bukhari, excuse me, like Jim Carrey, Mr. Bukhari. Anyway, I see you. Okay, so the simplest way we have to graph something like this is create a table. It's hard to hear my voice. Okay, let me try like this. So, ooh, hopefully it doesn't get too loud. Just let me know. Let me know how the audio is. But yeah, I can. So I see your comments. Let me see. Yeah, I turned up the audio, so hopefully it doesn't get too loud. So just let me know. So we're making a table, right? So we choose the x values, find the corresponding y's, and plot the points. Okay, so I'm gonna turn this down because I can't. When I listen to myself talk, then I start listening. I can't like think and listen at the same time. I have to do like one or the other. Okay. So yeah, we could plot the points and we get a graph like this. So this is the basic shape of a quadratic. Domain is the very left to the very right. The range, the very bottom to the very top. So I'm not going to go deep in on that right now because we've kind of talked about that in excess. So with quadratics, we have this thing called the axis of symmetry. So when you think of things that are symmetric, you know, like you can draw a line down the middle and the left half is an image of the right hand side. Okay, I see where it says it's better. Oh, also there's a delay. So like where I can see you guys live comments on my end, there's a delay between me doing stuff and you all being able to hear it. So, but anyway, so we have this axis of symmetry. It's going to go through the x coordinate of the vertex, right? So we can use this axis of symmetry to plot parabolas. Whenever we get a point on the left, we can use the axis of symmetry to get a point on the right. All right, okay. So let's keep going. So this is called, it should be the standard form of a quadratic. We would get to this by doing completing a square on a quadratic, and then we can get into this form. I'll do at least one demo on completing a square to get it into this form. But you know, it can be kind of a challenge, and you know, we have a few different techniques, and so we'll see it in action. We'll just kind of let that be for now. I didn't really want to see the graph of that one. Okay, I think I want to do a quick demo on completing a square. And actually what I think I'm going to use, well, I can do it here. Actually, I'd rather use this guy. I'm just a fan. I'm just so used to using like Notability. It works really well for me. So I'm gonna go back to the PowerPoint. Okay, that's fine. Hopefully I didn't turn it off. Okay. So I'm gonna get a copy of this. Oh no. You're not gonna work for me? There it is. So I know it says by plotting points, but I just want to do a quick demo on completing a square. So with this example, we're actually fortunate because the leading coefficient is already a 1, right? So let's see this in action. Say we wanted to get this in standard form and we wanted to use completing a square. So let's get a copy of the original and let's do this, and let's go like this one. Actually, let's go here. Okay, so here's a copy of the original. We have this f of x equals x squared minus 4x minus 2, right? So yeah, so like if you have a nickname, I'm not gonna know who you are. Just in the comment section, just say, hey, this is so and so from We Meet Tuesday, blah blah blah. You know, so that way, because you don't want to do it in the live chat because when I close it out, the live chat's gonna go away. And actually, let's Hello, hello. Ooh. Okay, sorry about that. I don't know how that got turned down. Let's turn it down a little bit more. Okay, so let me, well, I'm not gonna, I'm gonna let the last one be, so if you didn't hear it or if it didn't go through, that's okay. So, but I'll kind of redo the extra credit. So I'll make this extra credit right here. So here, with the slide that's on the screen right now, let me see. So the base function is y equals x squared. So the base function is y equals x squared. There are 1, 2, 3, 4 transformations going on there. I'll give you a hint. Work the transformations from the inside to the out, but the first student to list out all 4 going from the inside to the out, list out all 4 transformations, I'll give you extra credit for that. Okay? So thanks for that note that you couldn't hear my voice. So I made the adjustment. I think you can hear it now. But again, so the first student, any of my students, you don't have to just be in college algebra. If you can list out the 4 transformations going from the inside to the out, if you can list out all 4 transformations, I'll give extra credit for this. Do it in the live chat, so that way, we can see who gets it. So I'm going to actually skip this one as well. I'll leave that one next as exercise. Okay, so this one, this one asks us, let me turn it down. I feel like it might be a little too loud. This one asks us, I want to turn it down just a little bit more. This one asks us to find the intervals over which the function is increasing or decreasing. So basically what we would do is graph it. So we did a demo on completing the square. I'll do one more demo on completing the square, but then I want to show something else. Let me see. I don't think this one is too bad. Actually, this one is kind of bad. So instead of doing completing the square on this one, what I'm going to do, I'm going to introduce this formula. It's called the vertex formula. So let's go like this. Blue is fine. So the vertex formula goes something like this. So the x coordinate of the vertex, which is our h, is going to be negative b over 2a, right? Those are going to be the coordinates of that's going to be the x coordinate of the vertex. So in this case, that's going to be negative 6 over 2 times 1, all right? So then that's 3. So then the x coordinate of the vertex is 3. So that if we want to find the y coordinate, of the vertex, which is our k, that's going to be f of h. So in this case, that's going to be f of 3, which is going to be 3 squared minus 6 times 3 plus 7, right? So then that's going to be, you mean something? Okay. So yeah, but actually what are they, right? So yeah, it's like they're non-rigid transformations. So you either have a vertical stretch or vertical compression. You're going to move it side to side. So yeah, I just list out what are those. There are 4 transformations in that scene. Just list them out for me. Like if you start with the base function, what are the 4 transformations that you're going to do? Based on that image that we saw. So to continue this one, let's see. We have what? 9, 6 and 3 is 18 and 7. That's a negative 9, so then that should be negative 2. So also with these presentations, if I walk away from an example, those rules still apply. If I walk away from an example and it's wrong and you correct me, I give extra credit for that as well. So here I'm saying that the coordinates of the vertex are going to be 3, negative 2. So then if that's the vertex, our axis of symmetry is going to be when x is 3. So let's just do a quick little graph, right? Over 3 and down 2. So the vertex is about here. Let's find the x-intercepts. So when x is 0, or sorry, let's find the y-intercept actually. When x is 0, y is 7, right? That's negative 2, so 7 is about here. So here's our axis of symmetry that we just generated. Notice we went left 3, we were at 7. So we can actually go right 3 and we'll also be at 7. So we'll get a graph kind of like this. I think the x-intercepts here are not clean. Okay. So here is another extra credit opportunity, only for the people that are in live attendance. Um, tell me the correct x-intercepts here. So what are there are some ways that we talked about the x-intercepts. Tell me what are the x-intercepts here. So, you could try to factor it, that might not work. So we have some other ways or other techniques that we talked about how to find the x-intercept. So, if anybody can kind of walk me through it. I know you only have access to the live chat, but if you can get that going, I give extra credit for that as well. Okay. So now, if the vertex is 3, -2, the leading coefficient is positive, so then that means the parabola opens upward, right? So then if this is our graph, remember we just kind of essentially just plotted points. We're asked to find the intervals over which is increasing, decreasing, or constant. So notice as we trace the graph left to right, let me kind of go like this. As we trace it left to right, first the graph is going down, right? So it's going down over from -infinity up to when x is what value? When x is 3. So it's decreasing from -infinity up to 3. Infinity always gets a parentheses, and in this case I'm going to say that 3 gets a parentheses as well. Usually just do open intervals whenever we talk about increasing, decreasing, or constant. Okay, 0, 7. What was it, 0, 7? Okay, yeah, that's the y-intercept, okay. All right, and then it's increasing, so as we go on the other side of x being 3, it increases from 3 to infinity, right? Like this, it's increasing. So we got those results. I'm gonna clear out this screen. So they use completing the square here. Okay, that's fine. Okay, so I'm gonna let that be. All right, so you see they get the vertex occurs at 3, -2, and I think we use the vertex formula, and that's fine. So then we have this axis of symmetry. So then they found a few additional points. I used the symmetry. So when I found the y-intercept, I noticed when we went left 3, we were at 7. So if we go right 3, we're also at 7. Few additional points, we connect them. So then it's pretty clear. So that's the same graph that we got when we did it by hand. Domain and range is the same, and then answer the question. So since the vertex is the lowest point, it's decreasing. You see that we got the same results that we got. Okay, so I'm going to keep going. Oh, I guess that would help. Yeah, that's a lot easier for me to see. Okay, let's keep it going. Let's let that be. Identify the intercepts. Okay, let's do a quick demo on finding intercepts. I think I want to take this over to notability. I just like the feel of notability a lot better. All right, we're gonna take that and drop it there. Boom, just like that. Okay. All right. So, let's see. We're asked to identify the intercepts of this graph. Let's go like this. So now, whenever I'm working intercepts, I definitely recommend starting with the y-intercept first. More often than not, it's easier in my opinion. If we're going to find the y-intercept, what do? We set x equal to 0, right? So if we do that, we're basically going to do f of 0. It's going to be -3 times 0 squared minus 2 times 0 plus 1. So then what happens? That goes to 0, that goes to 0, and our result is 1, right? So the y-intercept is going to be 0, 1. Let's find the x-intercept. So what do we do for that? We're going to set y equal to 0 and solve. Okay. So if we set y to 0, we're going to have -3x squared minus 2x plus 1 equal to 0. Let's see. We could use quadratic formula. I'm trying to think. Okay, I'm gonna do a demo on the AC method of factoring. So for the AC method, if we say the A times the C, we're looking for two numbers that multiply to give us the A and the C. So we say A times C. Here's our A right here. Here's a C right here. So there are two numbers that multiply to give us -3 and add to give us -2. I'm going to just go through the list. So we have -1 and 2. Sorry, -1 and 3. Notice those multiply to give us -3 and 8. And actually, we need to switch the signs. They add to give us -2. So we're going to rewrite this -2. Didn't mean to do that. We're going to rewrite this -2 using the 1 and the -3. So we're going to rewrite -2 as -3x plus x. And then everything else just comes down. So this -3x squared comes down. This +1 comes down. This and this. Okay. All right. So let's keep it going. Okay, so if we look at the first two, we can use factor by grouping. What can we factor out of the first two? So we can factor out what, a -3x, and then what's left? We got an x plus 1. We're kind of anticipating another x plus 1 on this other side. All right. So the greatest common factor for the two on the right is just a 1. Then we factor out the common binomial factor. In other words, we mean the common color. What color do these two terms have in common? They both have the blue, right? So we could factor out the blue. It's kind of like a merge almost, right? We could factor that out. They essentially merge. And then what's left? If we remove the blue from the first part, we're left with the -3x. If we remove the blue from the second part, we're left with the +1, all right? Equals 0. So then from here, we have the zero factor property. We say that if two things multiply to give us 0, either the first thing is 0, the second thing is 0. So we say x plus 1 equals 0, or -3x plus 1 equals 0, all right? Where did we get the -3x plus 3? Oh, okay. So what we ended up doing, the -2x, so we use a technique called the AC method of factoring. The -3x plus 3. So we were looking for two numbers that multiplied to give us -3 and added to give -2. That ended up being 1 and -3. So let's choose a color. Let's go with this color. Actually, let's choose this color. Okay. So this -2 here, we rewrote it using this -3 and this 1. So we rewrote it as -3 plus 1, like this. So we rewrote the green into this. So then we use a technique called factor by grouping. What did we group out of what could we factor out of the first two was the -3. The second two only had a 1 in common, so there's an implied 1 here that I'm not writing. And then, but this technique is called the AC method of factoring. AC method of factoring. I'm gonna delete that. Okay. So then x equals -1. If we subtract, x equals what? 1 over 3 positive. So let's go back. Oh, so we found our y-intercept. So our claim is that the x-intercepts are -1, 0 and 1/3, 0. All right. So that's all that this question asks us to do. The y-intercept and the x-intercept. Let's go back to the PowerPoint. So now they're using completing the square here. This one, okay, notice that the first thing for completing the square is that the leading coefficient has to be a 1. So if we try completing the square here, it's going to create fractions everywhere. And not that it's impossible, it's still the same step, but I know that intimidates a lot of students. So that's why I kind of left that. Ms. Kumanji, let me know if that made sense or not, or if I need to kind of go further into detail on the -3x plus 3. Okay, so but the completing the square steps are the same. You just have to kind of take your time and incorporate fractions. Oh, so we weren't finding a vertex though. We weren't doing any of that. We were just identifying the intercepts. So I'm gonna let that be. Okay. But now something like this, if I wanted to find the vertex, I would use the vertex formula. Again, the negative b over 2a. So if we said 2 over 6 is a third, right? Negative 1/3. Okay. So we found these because we were just answering the question being asked. So yeah, we got that. We got those results. Okay, so we had the x-intercepts and we had the vertex. We see it opens downward. Okay, I'm going to let that be. So again, this, I want to say this is supposed to be called the standard form. Anyway, again, so yeah, here's the the vertex formula. Okay, thanks. I got it. I see what you. I gotta see. Like, I know there are ways to do like alerts when people respond and stuff like that. I don't know, but I'll get into all that later. So this is what we've been using, the vertex formula. The x coordinate of the vertex, which is your h, which you see in red here, is going to be the negative b over 2a. So given the general form of a quadratic, we can use this to quickly find the x coordinate of the vertex. And then the y coordinate of the vertex, you take that answer and plug it into the function. This is just an overview or a summary of what we've been talking about with quadratics. So I'm going to kind of leave this for you as well. Okay, here we're asked to find the axis and the vertex of the parabola having this equation. So again, if the axis for the vertex, to me, the simplest way is just use the vertex formula. Yeah, that's fine. We can use this. Again, so the vertex formula, the x coordinate of the vertex is our h. It's going to be negative b over 2a. So then that's going to be, our b in this case is 4 over 2 times our a in this case is 2. Okay. So then that's going to be negative 4 over 4, which is negative 1. Okay. So that's the x coordinate of the vertex. Let's go ahead and find the y coordinate. So then the y coordinate of the vertex, which is our k, is going to be f of h. So in this case, it's going to be f of negative 1. So that's going to be 2 times negative 1 squared plus 4 times negative 1 plus 5. So then that's going to be 2 minus 4 plus 5. That's 3, right? So our claim is that the coordinates of the vertex are going to be negative 1, 3. And then axis. So the axis is always just the x coordinate of the vertex. So once we have the vertex, then we'll say the axis of symmetry is just going to be x equals negative 1. So that should be it there. Negative 1, 3. I'm going to clear this out. We got our negative 1. And we got our 3. Okay. And yeah. Okay. So the axis, again, is just the x coordinate of the vertex is x equals negative 1. And then the vertex for the y coordinate, just plug in that plug in the x value for the y into f. Okay. Let's see. So here's an example on an application of a quadratic. Let's see, it says, if air resistance is neglected, the height s in feet of an object projected directly upward from the initial height of s naught feet with the initial velocity of v naught feet per second is given by this. So this is just a position function where t is going to be the number of seconds after the object is projected. So this is just a general function or formula for a position of an object based on time given an initial position and an initial velocity. So this is just an application of a quadratic. What it is something like, I don't know, you could have something on top of a cliff and you throw it and it's gonna take the shape of a upside down parabola. It's gonna go up, have a max, and then fall. It could be a rocket launching off the ground. Those typically have are parabolic in nature. The path that they take is typically like a parabola. So let's see an application. So we have that a ball is projected directly upward from an initial height of 100 feet with an initial velocity of this. Give the function that describes the height of the ball in terms of the time t. So we actually need a copy of this. So I'm gonna do some things. I'm gonna get a copy of this. Actually, I just really need the formula. And I'm gonna drop that right here. Just like that. And then I'm also going to go get a copy of the question, actually. Okay. And then let's get a copy of the question. Okay. I'm going to drop that there. Okay. So, and let's crop. Okay. And let's switch this around. I think it just makes a little more sense. Okay. So we have this ball is projected directly upward from an initial height of 100 feet with an initial velocity of 80 feet per second. Give the function that describes the height of the ball in terms of time, right? So the position based on time is going to be given by this negative 16 t squared plus our v naught is 80 feet per second. So that's going to be 80 times t. And the initial position is going to be 100, right? So that would be it. You just had to plug in the v naught and the position. So let's see, how do we do? That's exactly what we got. Okay, the next question. After how many seconds does the projectile reach its maximum height? What is the maximum height? Okay. And let's go like this. Actually, let's do this. Nope. All right. So then after how many seconds does the projectile reach its maximum height? Hey, we got a new person in attendance, Mr. Stinker Kill. Uh-oh, we might need to get some professional names if we're going to be doing live sessions on YouTube. I have no idea who that is. But yeah, so again, so for those in attendance, again, this is actually an extra credit opportunity. This is going to be open for 24 hours after I finish the videos for the night. So I'm just going to kind of power through the night as best I can. It's already getting late. If if you just check in, that's fine. If you want to go to the comment section, so you should be able to. The live chat is one thing, but what's better is if you can leave a comment. You might not be able to do it. I don't know when you can leave the comment. You might be able to do it now or not. But I'd rather you check in the comments, because the live chat is going to close out, and so I'm not going to be able to see it, once I kind of close it out. Okay, but the live chat should persist. So, and I'll kind of honor extra credit attendance for the next 24 hours after I end these videos. So after how many seconds does the projectile reach its maximum height? Okay, so if we look at our formula, we have this t squared. The highest exponent is a 2, right? So that means it's going to be a quadratic. And notice that the leading coefficient is negative. So that means the parabola opens downward. So if we have a parabola that opens downward, something like this, does this have a maximum value or a minimum value? Notice, if it's opening downward, that means those legs go down to negative infinity, and we never reach negative infinity. But there is a maximum value, right? It occurs at the vertex, right? So then, what's the maximum height? The maximum height is going to occur at the vertex. So let's find the vertex. So if we want the vertex, we can use the vertex formula. The x-coordinate of the vertex, which is our h, is going to be negative b over 2a, right? Okay. So then that's going to be negative 80 over, there it is, over 2 times the negative 16. What is that, 32? Is that like 5? I bet you that's 5. You know what? So I'm going to do a demo using my trusty dusty rusty. Hopefully it should work okay. Let's go here. Oh, I got to turn that off. Okay. It'll be okay. I don't have nothing. Yeah, I know. Nope, that's not what I want. Let's close all this out. We want to use our trusty dusty rusty. Come on. And boom, looking good. Okay. Oh, yeah, I just want to crunch this number. So we're going to do negative 80 divided by 2 times the negative 16. Oh, 2.5, right? 40. Yeah, I guess so. 2.5. Okay, I'm going to turn the airplane mode off again. Let me just kind of work it out real quick. We get this, right? This, negative 32. These are both at least divisible by negative 8. So we would get 10 over 4, 5 over 2. Okay, that's fine. So after how many seconds? After 2.5 seconds. So when the time is 2.5 seconds, it'll be at a max. At max. What is the maximum height? So if it occurs after 2.5 seconds, then the maximum height is basically the y value. So they want let's do it like this. The y value, which is our k, that's going to be f of h. In this case, it's going to be f of this 2.5. So then that's going to be negative 16 times 2.5 squared plus 80 times 2.5 plus 100. So again, I'm going to use my trusty dusty rusty. Oh yeah, I keep forgetting about the airplane mode. Maybe I'll just leave it on. So what I'm going to do, I'm going to go to my y equals right here. And I'm going to type in the formula that's at the top. So we have this negative. Oh, do I need to reload it? Okay, y equals. I'm going to do this negative 16x squared plus 80x plus 100. Okay, that's the original. I'm going to quit. Variables, I'm going to call up. So this is the function I just typed in, and we want to evaluate this function when x is 2.5. And we get 200. So the maximum height, so this ends up being 200 feet. So we have after 2.5 seconds, the projectile will be at 200 feet. So let's go back here and see how do we do. 2.5, and we get our 200. Okay. So for what interval of time is the height of the ball greater than 160 feet? Okay. So what we're going to do, take a copy. And drop it right here. Boom, just like that. All right. So what they're asking us to do is basically take our function, and we want to know when is this greater than 160 feet, right? So this is all they're asking us to do. So let's solve this inequality. So if we subtract the 160, we get this negative 16t squared plus this. If we subtract, is that a negative 60? Is greater than 0. So basically it's saying, hey, when is this quadratic or parabola greater than 0? So do we have a GCF? It looks like everything is at least divisible by 2. Let's divide everything by 2. All right. So we can factor out a 2. We'll get what? Negative 8t squared, 40t, negative 30. Okay. I think we can do another one. Can we do 4? Can't do 4. So let's do another 2. So if we factor out another 2, so we could have factored out a 4 from the beginning, but that's okay. Negative 4t squared plus 10t. Nope. Doing 2, right? So 20t minus 15. Okay. And I think that's it for the greatest common factors. So now what I'm doing here, basically, like if we were to graph this, we're saying when is this graph above the x-axis? We really just need to find the x-intercepts. Once we find the x-intercepts, now the way that we're really supposed to do this is factor it, find the x-intercepts. The x-intercepts break the number line up into segments, and then we just need to find the values of the y's in those different components. So let's see this in action. Let's see. Let's try the AC method of factoring here. Now we could use quadratic. I'm going to do the AC method. I want to do a demo on the AC method. So A times C, again, so I'm going to say the A times C. So this -4 times this -15. What is that, 60? So two numbers that multiply to give us 60 and add to give us 20. Now 60 is what? 6 and 10? So that's a 2, 2, 3, and a 5, right? So two numbers that multiply to give us positive 60 and add to give us 20. We're just going to go through the list. So 1 is 60, but that adds up to 61, so that's no good. We can do 2 and what? 2 and 30, and it adds up to 32, so that's no good. We can do 3 and 20, that adds up to 23, so that's no good. Can we do 4? Yeah, we can do 4 because there's a 4 right there. So we did 4. If we use that 4, we have 15 left over. But that adds up to 19, right? So that's no good. So now notice we're below the 20, so there's no need to go any further. Let me try one more. 5. Is that 12 and 17? Yeah. So we're going to get further and further away from 20. So it seems like we can't factor with integer results. So let's try the quadratic formula. Okay, so I think we said something like this. So the quadratic formula, we said the negative boy couldn't decide to go to the radical house because he was square and he missed out on 4 awesome chicks and it was all over by 2 a.m. Okay, I'm gonna let that be. Okay, so let's identify our A, B, and C. So our A is -4, our B is 20, and our C is -15. Okay, so if this is the case, that's going to be a -20 plus or minus 400 minus 4, -4, -15. Let's see, triple negative, that's okay. Let's see what happens. 2 times this -4. So 16. Let me use my calculator. What is that? 30, 60. 60 times 4, 240. So if that's, it looks like this is 400 minus 240. I think 240 is a proper number. -20 plus or minus -8. 160. Okay. 160. I think that's okay. -8. Okay. So that's what, 16 and 10? So 16 is yeah, we'll check that out later. So square root of 16 is 4. So we have this -20 plus or minus 4 times the square root of 10 over -8. We could distribute the -8, or let me see, we could divide everything by, we could factor out a -4 from everything. So that's going to become a +5. Still plus or minus square root of 10, and that becomes a +2. Okay, what did we just find? Oh, so those are decimals. Let's find those decimals just to get a sense of where they are. So if we said 5, let's do it like this. Oh, is it because I'm on airplane mode? No. Okay. So if we said 5 parentheses 5 minus the square root of 10, we're going to say divided by 2, we get this result. And then let's do that same thing, but we're going to say plus. Okay, so these numbers are like approximately 0.9189, and then the other one is 4.08114 is fine, right? Just to get a sense of those decimals, right? So what this does, this gives us 2 points. So we have this 0.92 whatever, and then this 4.08 whatever, right? So it breaks the number line up into 3 parts. We have the far left, the middle, and the right. These are going to be our zeros, so these are our x-intercepts. So then we need to find the y value in each corresponding section, all right? Let's choose, like, this color's fine. Okay, So again, these zeros break the number line up into three sections. We got this far left, we got this middle section, and we have this far right. Right. So what we want to do is find the corresponding y values in each of these three sections. So if we choose a number to the left here, maybe something like 0, 0's to the left of this. So if we plug 0 into the original, you see we get a negative 15. So what that means is that all the x values over here are going to be negative or below the x-axis. If we choose something between these two, so something in between these, maybe like 1, when x is 1, all the y values are going to have the same sign in between. So if we plug 1 in here, if we plug a 1 in, that's going to be negative 4, that's going to be positive 15. Is it 0? Oh, no. Negative 4, that's 16 minus 15 is a positive 1, so it's going to be positive. All right. So what that means is that all the y values in here are going to be above the x-axis, and then something to the right is like 5. So if we plug 5 into the original, what is that? A negative 100? That's 0. That's going to be negative, right? Ultimately, it's going to be negative. So that means that all the y values here are going to be below the x-axis, right? So essentially what's going on is that we have a quadratic that's kind of behaving kind of something like this, right? This is what it's doing. So the question asked, for what interval of time is the height greater than 160? So when is it above the x-axis here? So we see between these two x values. So the interval is going to be something like this. 5 minus the square root of 10 over 2, and 5 plus the square root of 10 over 2. Yeah, parentheses. Which is, or you can say approximately between 0.92 seconds and between 4.08 seconds. All right. So we're going to go with that. Okay. Let's see what we got going. So let's go back to the PowerPoint, see how do we do. That's what we did. We set it to 0. Now they divided everything by negative 4. Did we divide by negative? I think we kept ours negative. Let me see. Yeah, we kept our leading coefficient negative. Oh no. We kept our leading coefficient negative, so I'm going to stand by my answer. They did this a little different, but let's see. We should get yeah, they used the quadratic formula. I think that's what we use as well. So yeah, we got those same numbers. Divide the number line up. Okay, so right here. So between those two time intervals, right? So we got it correct. Okay, I think we're almost done. I am kind of fading a bit. I kind of want to, 32 or 38. So if it's asking when is it going to get on the ground, with those initial conditions, basically they want to know when will the height be 0. I don't know what that no is referring to. Oh no. Yeah, I don't know what that no is referring to. Okay. Anyway. So we just said when the height is 0 and then solve that equation. You can actually use the quadratic formula again. And then again, a negative time in this context doesn't make sense for this equation, so we say when time is approximately 6 seconds. Okay, I'm going to leave this as an example, as an exercise for you all. Okay. I kind of want to mention this. So we're asked to prepare a scatter diagram. So I know that we went on and assigned a critical thinking component. It's related to this. Okay. So we use a linear regression to determine the equations that model the data. We've kind of talked about this in class. I know we talked about it today. I know with my students in tomorrow, we're going to take some time to talk about this as well. Something of this nature. So notice this can be done using a graphing calculator like a TI-83 or 84 or something like that. You can also use Excel to do this kind of stuff as well. So we do have a critical thinking component in our Moodle page. You want to open it up, take a look at it, ask me questions, email me. You can team up, and I think you actually submit it on Moodle, and we're going to make it due at exam 3, which is next week. So you have 1 week to kind of go ahead and get that submitted. You want to just go ahead. I don't think it's too bad. My students today seemed like they were okay with it. Like they didn't seem like they were having too hard a time with it, but you know, only time will tell. Okay. So this is what you see at the bottom right hand corner of the screen. You have this quadratic regression. That's doing TI 83 plus or whatever, or at 84. But it can generate the A, B, and C for the line that's going to be a best fit. Now this is a quadratic. I think for our critical thinking we did linear, but it's just a line that gets as close to the data as we can. Okay. So I'm going to leave this as an exercise. And all right. So we're going to take a break there. I actually think I'm going to let it keep running. I am going to take a quick break. Actually, I'm just going to stop the stream and I'm going to stop it and I'll start it back up. We're going to come back after like 10 minutes. I'm going to take some time. Okay, so we're going to let this one be just for 3.1. I'm going to pause everything and we'll come back in like about 10 minutes or so. And I think I got enough energy to go ahead and start chapter 4. So I want to go ahead and do at least 4.1. All right. So with that, we will end the session here. And from one beautiful mind to another, enjoy the rest of your evening.